let's look at question number 3 on the 2022 AP Calculus AB and BC exam. This was a shared question, and I am reading the question for the first time, so I'm solving it in real time. So I may have to pause for a second to process some stuff. So we are given the graph of f prime. We have a differentiable function. F is differentiable. F of 4 is 3. So there's an initial condition. I kind of like that. I'm going to make a note that F of 4 is 3. We're on the interval 0 to 7. The graph of f prime consists of semicircle and 2 line segments. Cool. F of 0 and F of 5. So F of 0, we have an initial condition, F of 4. And I need to add to that the change in F from 4 to 0. We're going backwards, as some of y'all would say. And we will compute that integral by analyzing areas. So there's my setup. And from 4 to 0, we're going from right to left. That's a negative direction. The graph is also below the x-axis, so that's a negative position, so to speak, of the graph. So that'll be a positive area, and that is half a circle with radius 2. So plus 1/2 pi 2 squared. And if you really want to show off, you could call that 3 plus 2 pi for your F of 0, but I would probably put a line through that on my AP exam just in case I messed that up. And that way my written answer here would be the last thing that is graded. And then F of 5, same setup, initial condition. We know what's happening at 4. I need to know how much F changes from 4 to 5, which is the area under F prime from 4 to 5, which that would be, looks to be a unit of 1/2. That's just half a square. So that's going to be F of 4 is 3 plus 1/2, which is 7/2. And I feel pretty confident in my arithmetic there. So I'm just going to leave it like that. Find all the points of inflection on the graph of F from 0 to 7. Okay, so for inflection points, you generally think that you want to find places where the second derivative of F changes signs. That also happens to be places where the first derivative of F has local extrema. And I can look at this graph and I can tell that F prime has local extrema. At x equals 2, which will be the bottom of that semicircle, and x equals 6. That is a non-differentiable point. However, that is still a local maximum, even though it is a corner. F has local extrema. F prime has local extrema at x equals 2 and x equals 6. Therefore, F has inflection points. At x equals 2 and x equals 6. Let me double check that. Find all x coordinates of inflection points. I like that. If you want to kill this dead, you could say that F prime has local extrema. Anytime a graph, regardless of whether it's F prime, F double prime, whatever, anytime a graph has a local extrema, that will happen where that graph's derivative changes signs. So F prime has local extrema where F double prime would change signs, which is your definition of an inflection point. So I'm just adding that second little piece because I kind of like, when I think inflection points, I really like thinking second derivative changes signs. But it is also true that if your first derivative has a local extrema, that is the location of an inflection point. Let's go on to part C. G is this function, f of x minus x. On what intervals is G decreasing? So we need to know where G is decreasing. So our game plan is, where is G prime negative? So G prime of x would be the derivative of f of x minus x, which is f prime of x minus 1. And for G to be decreasing, I need that thing to be less than 0, which is going to be when f prime of x is less than 1. And I'm looking at this graph, and f prime of x is less than 1 on the interval 0 to 5. So 0 less than x is less than 5. Show the work that leads to your answer. I feel like I have done that. So I could say, therefore, G is decreasing on the interval 0 less than equal x less than equal 5. And I do like to include those endpoints. I don't think they will count off if you do not. I don't think they will count off if you do. And the gradings, the scoring criteria say not to. But so I'm going to leave my answer like that. Show the analysis that leads to your answer. So I found the derivative. I showed that I'm finding when the derivative is less than 1. We are looking at the graph of the derivative. I feel good about that. I don't think there's much else I need to do to thoroughly kill that part dead. So let's move on to D. For the function g found in that bar, find the absolute minimum value and justify your answer. So we want the absolute minimum, and anytime you want absolute minimum, you want to consider endpoints and critical numbers. So again, I'm going to, I don't like how little work I have for part C. That's bugging me. That's really bugging me. Should I do a sign analysis? I think I may. I think I'm going to go back to C. I'm just going to be thorough on part C. I want to make sure that I've covered my bases. So what I'm going to do, even though number lines are invisible, they do not count as work shown, I'm going to find out when this is less than 1 by considering the number line for G prime. And so G prime will equal 0. I'm going to do this. And f prime of x equals 1 at x equals 5. So the only critical number for G prime is at 5, and that does make G prime equal to 0. I'm going to pick some test points. I'll plug in G prime of 0, and I'll plug in G prime of 6. And remember, the number line is invisible, so I need to actually write down G prime of 0 is equal to f prime of 0 minus 1. F prime of 0 is 0. That is negative. And I'm going to move this down some more. And then G prime of 6 would equal f prime of 6 minus 1. F prime of 6 is 2 minus 1. That is positive. And so I can now say that, therefore, G of x is decreasing on 0 to 5 because G prime of x is less than 0 on 0 less than x less than 5. Now G prime does actually equal 0 at 0 and 5, so I'm not including it on that part. Again, not too worried about the equals 2 on those two pieces. So, all right. So I wanted to go back and revisit that one. I feel a little bit better about my explanation there for part C now. Okay, so now let's move on to D. And D, again, we want the absolute minimum of G. So we want to consider the endpoints, which will be x equals 0 and 7. 0 and 7. And my critical number would be x equals 5, and that's from part C. So I'm just going to make a note that is from part C. And now I need to determine which of these gives me the highest and lowest values of G. And so G of 0 would be, and G is f. So that'll be f of 0 minus 0. F of 0 is in part A. I can go all the way back up here to part A, and we found out that f of 0 was 3 plus 2 pi. I need G of 5, which will be f of 5 minus 5. That was my critical number. At 5, f's value was 7 halves. So we have 7 halves minus 5 is negative 3 halves. And I already know that's going to be my minimum, and I'll explain in a second how I know that without even testing the right endpoint. G of 7 would be f of 7 minus 7. And I'm going to go over here and I'm going to figure out f of 7, which will be your initial condition at 4 plus the area from 4 to 7 under the function f prime of x. And there's another way that I could do this probably a little bit more efficiently, but I've already kind of gone in this deep with this approach. So the integral from 4 to 7, I see 1 to 3.5 for the area. So that's 6.5. And so now I have the value of G at each of my candidates, and it says find the absolute minimum value. So the value is the y coordinate. So the minimum of G is, I'll say on the interval 0 to 7, is -3/2. And if you want to kill it dead, you could say at x equals 5. But the answer is the y coordinate. And the other way you could have figured this out is if you look at the derivative, or if you look at the graph of G prime, if you were to consider G prime, we already know up here, and I should have done this, because I could have just piggybacked on part C, but in part C, I established that G is decreasing from 0 to 5, and I can look at this same work and conclude that G increases from 5 to 7. So if I know that G decreases from 0 to 5 and then increases from 5 to 7, then by default, that critical number, that local extrema at 5, that local minimum would have to be lower than the two endpoints. And that is another way that you could have justified that the local minimum occurs at x equals 5. Now you still would need to go in and actually find the value, G of 5 being -3/2. So don't stop by just saying the local minimum or absolute minimum is at x equals 5. And that wraps up question number 3, and I'm ready to move on to number 4.